Dear Facilitators International Study Channel followers, how are you? Welcome to Facilitators International Study Channel Grade 12 Mathematics lesson in Ethiopian curriculum. My name is Yamata. If you're interested in my presentation, you can subscribe, comment, like, and also share. Now, let us start our today's presentation. Guys, today we will see some exercises on the limit of sequences. So, the first part is, let's say, evaluate each of the following limits of sequences. So before this, in the previous class we have seen that the properties of limits of sequences when two sequences are said to be converted. Say for example, the limits of the function, the sequence n as n approach to infinity equals to L, and the limits of the sequence, another sequence Bn, when n approaches to infinity, which equals to certain real number m. So we have seen already which is the operation, which is addition, subtraction, multiplication, division, and also what's the constant multiples of sequences. So now relating to that, we'll see some exercises on the limit of sequences. So the first part is the limit of the sequence, which is 2n plus 1 over 2n plus 5 times of 5n plus 1 over 6n minus 2 minus 5, we can say like this, when n is approaches to infinity. Second problem is evaluate the limit of the sequence of the form which is 1 plus 2 square plus 3 square plus up to say n square over n to the power of 3, when the value of n is approaches to say infinity. The third problem or exercise is the third part, the limit of the value, the square root of the n square plus 5 over n plus 1, as the value of n is approaches to say infinity. Then the fourth part is says that the limit of the sequence n square plus 1 minus 3 over say n plus 2, as n is approaches to say infinity. And the fifth one is the evaluate the limit of the sequence say n plus 3 over radical n plus 1 when n is approaches to infinity. All these are what we want to show, how to calculate or evaluate the limits of all those sequences for today. In this case, we have seen before, which is we have a sequence here. Let's say the sequence the form of an over bn, or the sequence of the form an times of another sequence bn as a product, and these also different types of forms of the sequence. So we'll see each of them. Now let's see the solutions. Solution. So a part, it says limit. So the limit of the sequence of the form here 2n plus 1 over 2n plus 5 times of 5n plus 1 over 6n minus 5, like this. When the value of n approaches to infinity, which is positive infinity. So this is equivalent to the limit of the sequence of the form which is 2n plus 1 over 2n plus 5, when the value of n is approached infinity, times the limit of the sequence 5n plus 1 over 6n minus 5 when n is approaches to infinity, in such a way. Why this is happened? Because what I'm saying in the previous class, the limit of the sequence two sequences, the limit of the sequence an times of bn as n approaches to infinity is exactly equals to limit of the sequence an times the limit of the sequence bn when n is approached to infinity, when n is approaches to infinity, provided that the limit of n when n approaches to infinity and limit of bn when n approaches to infinity are convergent sequence. So we can use the formula in such a way. By that formula, we can determine, or it says that the limit of the sequence 2n plus 1 over 2n plus 5 times of, which is 5n plus 1 over 6n minus 5, is when the value of n is approaches to infinity is exactly equals to the limit of the sequence, which is the form 2n plus 1 over 2n plus 5. When n is approaches to infinity, 5n plus 1 over 6n minus 5, when the value of n is approaches to infinity. Therefore, this is happened because the formula we have seen previously, the limit of the sequence, two sequences, an times bn, the limit of the sequence an times bn, when n is tends to infinity or approaches to infinity, is equals to limit of the sequence an when the value of n approaches to infinity times limit of the sequence bn when the value of n approaches to infinity. We have the form previously this formula, so we can apply that one. So from this we can say here the limit of the sequence an plus 1 over 2n plus 1 plus over 2n plus 5 means that we can evaluate the limit here. The denominator, the denominator part, we have 2n plus 5. Therefore, the highest degree of the denominator part is simply 1. Therefore, we can divide the denominator and numerator by the largest degree of the denominator variables. Or so we can say here limit of the sequence as n approach to infinity, which is 2n plus 1 over n over, which is 2n plus 5 over n, the whole as n is approaches to infinity, times the same fashion here the limit of the sequence, which is when n is approaches to infinity, 5n plus 1 over n, the whole over, which is 6n minus 5 over n. So the value as n is tends to infinity. Why this doing it over n over n? What we are saying is dividing the denominator and numerator by the largest degree of n in the denominator. This means here in the denominator to n plus 5, so we can divide every terms of this sequence by the value of n, and we can divide here, we can observe 6n, therefore we can divide by n for every terms from numerator and denominator. Therefore this can be simplified as the limit of the sequence as n approaches to infinity, which is in this part to n over n plus 1 over n, which is equal to simply 2 plus 1 over n, over, which is equal to 2 plus 5 over n, when n approach to infinity, times limit of the sequence, which is 5n plus 1 over n, means that 5 plus 1 over n over 6n over n means 6 minus 5 over n, when n is approaches to say infinity. Why this happen here to n plus 1 over n means, like this here, we can say two numbers, say a plus b over c, means that a over c plus b over c. Because here to n plus 1 over n means to n, so to n plus 1 over n means that 2n over n plus 1 over n, so which equals to here 2 plus 1 over n. So in the same, so this is exactly equals to, now evaluating the limit, so you can apply the formula, limit of the sequence 2 plus 1 over n over 2 plus 5 over n, means that the limit of the sequence, which is 2 plus 1 over n, when n is approaches to infinity, over this part, again, limit of the sequence, which is 2 plus 5 over n, as n is approaches to infinity, times the same fashion here, limit of the sequence, which is 5 plus 1 over n, when the value of n approaches to infinity, over here, which is again limit of the sequence, which is 6 minus 5 over n, when the value of n approaches to infinity. Why this is happen? Because we have learned before previously the two limits, which is limit of the sequence an over bn, when n approaches to infinity, means that the limit of the sequence an, when the value of n approaches to infinity, over the limit of the sequence bn, when n is approaches to infinity. We have seen this previously. Therefore, we can apply that formula. So this is exactly equals to the limit of the sequence 2 plus 1 over n, as n approaches to infinity, means we can apply again, this is two limits, two sequences, as 2 is sequence an, and 1 over n is sequence bn. So we can apply the formula also, which is the limit of the sequence an plus bn. But for that, here we can evaluate. So the limit of the sequence here. So this is exactly the limit of the sequence 2 as n approaches to infinity, plus limit of the sequence 1 over n as n approaches to infinity, over here limit of the sequence, which is 2 when n approaches to infinity, plus limit of the sequence 5 over n when n approaches to infinity, times again limit of, from this part, limit of the sequence 5 when n is approached to infinity, here times in such a way, plus the limit of the sequence here 1 over n when n is approaches to infinity, over here limit of the sequence 6 when n approaches to infinity, minus the limit of 5 over n when n is approached to infinity. This part, from this we can apply the formula here, the limit of the sequence an plus bn, or minus when the value of n approach to infinity is exactly equals to limit of the sequence an as n approaches to infinity, plus the limit of bn when n approaches to infinity. If it is minus, this should be minus. So we're already applied this 2 is as a sequence n, this 1 over n is as a sequence bn, so we can apply the formula we have mentioned previously. Now we can recall that for any constant number, limit of the sequence, let's say c, when the value of n approaches to a certain which is infinity, is equals to always the constant number which is c. So the limit of any constant sequence is always the constant itself. Therefore here we can evaluate the limit of 2 when n approaches to infinity is 2 plus the limit of 1 over n as n approaches to infinity is 1 over n. When the value of n becomes larger and larger, so the value of 1 over n becomes, say, 0. So this result is 0 over. Here the limit of the constant number is, say, 2 plus 5 over n as n tends to infinity is 0 times of, and again here limit of the constant 5 as n approaches to infinity is 5 plus the limit 1 over n as n approaches to infinity. When n is become larger and larger, so 1 over n becomes smaller and smaller, which is closer and closer to the number which is 0. So the result which is equal to, say, 0. And again, the limit of the sequence which is constant 6 when n tends to infinity, so the sequence of constant limit is always the constant, minus here a limit of 5 over n when the value of n approaches to infinity. When n becomes larger and larger, 5 over n becomes closer and closer, smaller and smaller towards the value, say, 0. Therefore, when we simplify here, 2 plus 0 is 2, 2 plus 0 is 2, 2 over 2 is 1. So here it is equal to 1 times 5 plus 0 and 6 minus 0. So which is equal to simply 5 over 6. So 1 times 5 over 6, the result is 5 over 6. Therefore, our result, which is the limit of the sequence to n plus 5 over to n plus 1 over to n plus 5 times 5n plus 1 over 6n minus 5 is equivalent to, which is some fixed real number, which is equals to what? 5 over 6. Actually, in this case, when you observe here, we have to the same degree here it is also the same degree. So the limit is which is equals to what? The horizontal asymptote. Pause the horizontal asymptote from this part is the coefficient of the highest degree and the coefficient of the highest degree, which is 2 over 2, which is 1, since it is multiplication, times of, and the same fashion here, 5n plus 1 and 6n minus 5. Therefore, the coefficient of the highest degree here it is 5 and 6, so which is equal to 5 over 6. Therefore, 5 over 6 times 2 over 2, because 2 over 2 is already 1, so 1 times 5 over 6, the result which is equals to 5 over 6 ነው እናገኛለን ማለት ነው። ስለዚህ እነዚህ እንግዲህ ያየናቸው ምንድነው ካሁን በፊት የቤዚክ ሊሚት የሲኩዌንስን ቤዚክ ሊሚት ቴረም ያየንበት መንገድ እና እሱን አፕላይ የምናደርግበት መንገድ ነው ማለት ነው። እዚህ ጋር ግን እዚህ ለምን ወደዚህ ቀየር ነው የሚለው ነገር እዚህ የፕሮዳክት ቴረምን ተጠቅመን ነው ወደዚህ ቀየር ነው። እዚህ ስንደርስ ግን ወደዚህ ቅርጽ ወይም ፎርም ቀየር ነው። ለሴ ማየት ያለብን ምንድነው የዲኖሚኔተር ፓርቱን ትልቁን ዲግሪ እንወስዳለን። እዚህ ጋር ቱ ኤን ይላል። ሶ ዲግሪው አንድ ነው እና every terms of numerator and denominator we must divide the highest degree of that number. So we can divide denominator and numerator by the largest degree of n in the denominator parts. So we can divide this and this by n like this, to n plus 1 over n over to n plus 5 over n. When we simplify this expression is the same as this part. ይሄኛው expression ከዚህኛው ጋር ፍጹም አንድ መሆኑን ያሳየናል። በተመሳሳይ መልኩ ይሄን የምናያለን ትልቁ ዲግሪ ዶኖሚኔተር ላይ n ነው። ስለዚህ በ5n plus 1 እና 6n minus 5ን ለn እናካፍላለን ማለት ነው። Now እዚህ ላይ ይሄን ስናካፍል to n plus 1 ለn ስናካፍል we can apply the form which is a plus b over c means we can simply the same denominator a plus c plus b plus, which is decomposition ብለን የምንጠራው ማለት ነው። Therefore to n over n plus 1 over n የሚለው እናገኛለን። to n over n ማለት ግን 2 ነው so 1 over n ወደዚህ ሲምፕሊፋይ እናደርገዋለን now ከዚህ በኋላ ምንድነው ያየነው ካሁን በፊት ያየነው የኮኤፊሽንት limits of the coefficient of sequence the limit an over bn when n tends to infinity ማለት the limit an as n tends to infinity over the limit of sequence bn when n tends to infinity provided that the limit of the sequence bn should be differ from 0 የሚለው ካየን ስለዚህ ያን ፎርሙላ ተጠቅመን ይሄ ማለት assume this is an and this is bn so we can say the limit 2 plus 1 over n when n tends to infinity over the limit 2 plus 5 over n tends to infinity የሚለው ቅርጽ ይዘላል times of the same fashion በተመሳሳይ እዚህ የሰራው ነገር ለዚህኛው ተመሳሳይ እናደርጋለን ማለት ነው now ግን ከዚህ ደግሞ ወደዚህ ስንመጣ ምንድነው የሰራነው ውሃው ፎርሙላ here limit n plus or minus bn two sequences as an addition as n tends to infinity is exactly equals to the limit n as n tends to infinity plus limit of the sequence bn when n tends to infinity if it is minus should be minus so እሱን ተጽይዞልናል እና limit of 2 plus 1 over n የሚለው limit of 2 plus limit of 1 over n ወደሚል ቅርጽ ቀየር ነው every term is the same fashion ነገር ግን ማስታወስ አለባችሁ for any constant sequence in a sense the value of an is say for example c meaning is that a1 is c a2 is c a3 is c a4 is c a5 is so an is equal to in general which is c this sequence is known as constant sequence for any constant sequence the limit as n tends to infinity always the constant the number itself the same fashion here this 2 the number 2 since it is constant so the limit of 2 as n tends to infinity is exactly 2 but limit of 1 over n as n tends to infinity is equals to 0 because when the value of n becomes larger and larger the value of 1 over n becomes closer and closer to some fixed real number that is 0 so the same fashion here the limit constant we say 2 the limit of 5 over n when n tends to infinity is equal to say 0 so the same fashion here limit of 5 as n tends to infinity is 5 and limit of 6 as n tends to infinity is 6 so we have this and this is 0 when we simplify the result is equals to 5 over 6 ነው እናገኛለን ማለት ነው see this the second problem says that the limit as you see here from the problem the limit 1 plus 2 squared plus 3 squared plus 4 squared plus up to n squared over n to the power of 3 as n is approach to infinity what will be the limit which means limit 1 plus 2 squared plus 3 squared plus n squared over n is the power of 3 as n is tends to infinity so what will be our intention is to evaluate the limit of all this sequence now to perform this you have to recall that say for example the summation so 1 plus 2 plus 3 plus n which is equals to the sum which is n into n plus 1 over say 2 we have seen this before and again if it is 1 square plus 2 square plus 3 square plus say n square is exactly equals to n into n plus 1 times 2n plus 1 over say 6 which is the sum of the first n natural number is summarized as a formula n into n plus 1 over 2 and the sum of the square of the first n natural number can be calculated as n times of n plus 1 times of 2n plus 1 over 6 so you have to recall so the formula of this now this is exactly equals to the limit this formula is exactly equals to here which is equals to n into n plus 1 times of 2n plus 1 over 6 times of here it is since it is n cube, we can say 6n to the power of 3 as n is tends to infinity. Now here, when we multiply all this n times of n plus 1 times to n plus 1, we will get, which is simply, we have since the n we have so we can say the limit, which is as n tends to infinity, which is 2n the power of 3 plus 3n squared plus n over, which is 6n the power of 3. We can say here as n tends to infinity, when we multiply n by n plus 1 and again by 2n plus 1, we will get 2n the power of 3 times plus 3n squared plus n. So ይሄን እናገኛለን ማለት ነው። እነዚህን በምናባዛ ጊዜ ግን የዚህኛው ፎርሙላ ከየት መጣ? n into n plus 1 times 2n plus 1 over 6 የሚለው ከዚህ እንደመጣ ማስታወስ ይጠበቅብናል ማለት ነው። Now you can apply the tricks that I have told you before. አሁን እዚህ ላይ ስንደርስ ደግሞ ቀደም ያልኳችሁ ነገር ማስታወስ አለባችሁ። በዚህን ጊዜ እንደዚህ ሲመጣብን በቫሪያብሉ ከላይ ያለውና ከታች ኑሜሬተርና ዲኖሚኔተር የዲኖሚኔተሩን ትልቁን ዲግሪ የያዘውን ቫሪያብል ኤቭሪ ተርም እናካፍለዋለን ማለት ነው። ያ ማለት ምን ማለት ነው? ሊሚት which is as n tends to or approaches to infinity 2n cube plus 3n squared plus n over divided by the variable in the denominator with highest degree, say n cube, so we can say n cube over the denominator part is 6n cube, so 6n cube divided by here n cube, like this. All this as n tends to infinity. Now we can apply, as I told you before, here it is a plus b plus c over, so let's say d means we can say a over d plus b over d plus c over d. We can apply here. So which is to n cube over n cube plus 3n squared over n cube plus n over n cube. So this is exactly equals to the limit 2n cube over n cube means simply 2 plus 3n squared over n cube means, which is simply 3 over n, because 3n squared over n cube means that we have 1n here, so which is equal to simply 3 over n. Plus we can say here n over n cube means n over n cube, which means 1n by 1 is cancelled out, which is simply 1 over n squared, so which is the result is 1 over n squared over the whole system. Here it is 6n cube over n cube, which is equal to simply say 6 when the value of n is approaches to infinity. We can say like this. So this can be again simplified as the limit of here. We can apply the formula. We perform the limit of the constant 2, which is 2. The limit of 3 over n, which is infinity. Which is n tends to infinity becomes 0. So this becomes 0, and this becomes 0. This is 2, and this is 6 constant. So the result is 2 over 6, which is simplified as 1 over 3. So the limit of the sequence 1 plus 2 squared plus 3 squared plus n squared when n over n cube when n tends to infinity equals to 1 over 3 የሚለውን በቀላሉ ማግኘት እንችላለን ማለት ነው። ነገር ግን የዚህን ነገር ከአሁን በፊት ከምታውቁት ይሄን ማስታወስ ይጠበቅብናል። then simplify ማድረግ ይጠበቅብናል። so apply ትሪኮችን አብረን ማጫወት ማየት ተገቢ ይሆናል ማለት ነው። እነዚህ እንግዲህ በቀላሉ ልንሰራቸው የምንችለው ተመልካቾችን ልትገነዘቡ የሚፈልገው ፕራክቲክስ እናደርግ ነው። በየጊዜው ፕራክቲክ ማድረግ ስንችል ነው። ምክንያቱም ሂሳብ ሁል ጊዜ ፕራክቲክ ስለሚጠይቅ ማለት ነው። Now let's see the third problem. The third problem says that the limit square root of n squared plus 5 over n plus 1 at the value of n approaches to infinity, which means we can say the third one is limit the square root of n squared plus 5 over n plus 1 when the value of n is approaches to infinity. So this is exactly equals to the limit the square root of n squared plus 5. We can divide, we can observe the numerator part since it is n, so we can divide this by n over the whole over n plus 1 by n. In every terms we performed before as n is approaches to infinity. ምንድነው ያደረግነው እዚህ ጋር በተመሳሳይ ለኑሜሬተርና ለዲኖሚኔተሩ በተመሳሳይ በዲኖሚኔተሩ ከፍተኛ highest degree ባለው variable n ነው የምናካፍለው ማለት ነው። ማንን? ኑሜሬተሩንም ዲኖሚኔተሩንም ማለት ነው። ሶ እሱ ማለት ደግሞ n ነው። ለn ይሄኛውንም ስናካፍለው ኤክስፕሬሽን ይሄን ይመስላል። ስለዚህ ይሄ ሲሆን limit as n tends to infinity which is እዚህ ጋር ደግሞ ይሄኛው ስኩዌር ሩት ነው። ስለዚህ n ስኩዌር ሩት ሲገባ don't forget which is ምን ነው የሚገባው? ስኩዌር ነው የሚገባው። so which is equals to n square plus 5 over n square ይሆናል ማለት ነው። በዚህ መልክ ነው ለምሳሌ n times or simply 2 times radical 3 means when you see this is simplified for when we want to enter this number 2 inside here, so it must be square itself first, which means which equals to the square root of 2 square times 3, which is equal to simply 4 times 3 equals to 12 ነው እናገኛለን ማለት ነው። so the simplified form of root 12 is equal to 2 times of root 3 ሆነ እናገኛለን። so same fashion ይሄም ሲገባ ከሩቱ ሲገባ ስኩዌር ነው እናገኛለን ማለት ነው። over here n plus 1 over n means simply n over n means 1 plus 1 over n which is 1 over n the whole system as n tends to infinity. Therefore this is equals to the limit of the sequence which is the square root of n square over n square means 1. 5 over n square is simply 5 over n square over this part which is 1 plus 1 over n as n is approaches to infinity. We can say like this. Now we can apply here limit the square root of 1 plus 5 over n square like this as n is tends to infinity over this part limit the sequence 1 plus 1 over n when the value of n approaches to infinity. The division formula የሚለው ነገር እናገኛለን። ይሄን ራዲካል ያለው ሊሚት ስንሰራ limit of the sequence as n tends to infinity which is 1 plus 5 over n square as over all this should be under radical over the limit of the sequence 1 plus 1 over n when n is approaches to infinity. በዚህ መልክ እናገኛለን ማለት ነው። because you have a form ምን ብለን ነበር? አንደኛው ፎርሙላ the limit of the sequence which is radical an as n approaches to infinity is exactly equals to the square root of limit sequence an when n approaches to infinity የሚለውን ፎርም ተጠቅመን ማለት ነው። so radical ውስጥ ስናየው ይሄኛው constant 1 ነው። ይሄኛው 5 over n square since this n become larger and larger 5 over n becomes closer and closer to what the number which is say 0 and this becomes say the number with 0 simply the value which is radical 1 over 1 the result is simply radical 1 over 1 is 1 over 1 is the result is 1 so our answer should be 1 ነው እናገኛለን ማለት ነው። በቀላሉ በዚህ መልኩ ማየት እንችላለን ማለት ነው። Now when you come to the fourth problem, question said that limit root n square plus 1 minus 3 over n plus 2 when the value of n becomes or approaches to infinity. So it said that limit when n is approach to infinity the square root of n square plus 1 minus 3 over n plus 2 So this is the same we performed before. So since the highest degree for the denominator is n, so we can divide both numerator and denominator for every part is by n. So we can say the limit as n tends to infinity of the square root of n squared plus 1 minus 3 over n over n plus 2 over n, the whole system, like this. So when we insert this from the radical, we can, as we have said before, which is the square root limit when n tends to infinity, which is the square root of n squared plus 1 over n squared minus 3 over n. When we insert inside the radical, it must be a square, but it is outside as it is for n. Don't forget this part. Over the whole, which is n over n is 1 plus 2 over n is 2 over n, like this. The whole system as n tends to infinity. So this is exactly equals to the limit the square as n tends to infinity. Square root of n square over n square means, which is 1, and again 1 over n square with 1 over n square minus 3 over n over which is equals to 1 plus 1 2 over n, 1 plus 2 over n, the whole system, when the value of n is approaches to infinity. Now you can perform every terms, so you can apply the formula. So the limit of the numerator over limit of the denominator, we can say like this. So the limit inside the radicals, since n is 1 over n squared, so as n tends to infinity, this 1 over n squared becomes 0, so inside the radical simply 1. So, and again 3 over n as n tends to infinity, so this becomes what? Infinity. So the 3 over the very large number or infinity becomes 0. So 1 plus 2 over n as n tends to infinity, this becomes 0 and this becomes 1. So our result is simply 1 plus 0 inside the radical minus 0 over here 1 plus 0. So the result is radical 1 over which is 1. So our answer should be 1 ነው እናገኛለን ማለት ነው። በጣም እዚህ ላይ ነው ዋናው እንትን ያገኘነው። ከዚህ በኋላ ሲምፕሊፋይ ያደረጉ መሄድ ነው። ስለዚህ በቀላሉ ካልኩሌት ማድረግ እንችላለን ማለት ነው። Now when you come to the last problem, which is the limit of a sequence n plus 3 over radical n plus 1, as in the one of n approaches to say infinity, we can say here the fifth part limit as n tends to infinity of n plus 3 over radical n plus 1. Look, in such a problem, applying the same fashion over there is not preferable. Rather, we can use another form. So in this case, we can simply rationalize what you call, which is a denominator. What does mean rationalize? So making the denominator part as a rational form rather than irrational. So this is exactly equals to limit as n tends to infinity, which is n plus 3 over radical n plus 1 times some fixed number, that is 1. That is the number 1. But technically, this number 1 means equivalent to, so this part, which is radical n minus 1 over radical n minus 1, because any mathematical expression divided by itself except 0, the result becomes 1. So nothing is done here, simply multiplying in the number 1. And again, multiplying any mathematical expression by number 1 is, the result is as it is. So we can express this as in such a way. ምንድነው እቺኛውን ራሽናላይዝ ለማድረግ ኑሜሬተሩም ዲኖሚኔተሩም በተመሳሳይ ቁጥር ነው ያባዛ ነው። ያንም ታስታውሱ ከሆነ ራሽናላይዝ ለማድረግ ምንድነው እዚህ ጋር ራዲካል n + 5 + 1 የነበረውን ራዲካል n - 1 ኦቨር ራዲካል n - 1 በዚህ because ይሄ ራሽናላይዝ የሚሆንልን ቅርጽ መፈለጋችን ነው። therefore when you multiply numerator by numerator and denominator by the denominator part, this means the limit as n tends to infinity, which n times radical n is n radical n and minus n 3 times radical n, so 3 radical n, and again 3 times -1 is -3 over so this radical n plus 1 times radical n minus 1, which is a binomial formula. So you have to recall, let's say a minus b times of a plus b. So which is, this is a minus b and this is a plus b. The product is simply a square minus b square. So the same fashion here is the same fashion, radical n plus 1 times of radical n minus 1. So which equals to radical n square minus 1 square, which means radical n square means simply n, and here it is n 1 square means 1. So the result here it is simply n minus 1 as n tends to infinity. Now from this part we can apply the rules we performed here. አሁን እዚህኛው ስቴፕ ላይ ስንደርስ ቅድም እዚህ የሰራንበትን ማለትም ለዲኖሚኔተሩ እና ለኖሚኔተሩ ከዲኖሚኔተሩ ሃይስት ዲግሪ ያለውን n ወስደን ኤቭሪ ተርም ማካፈል ይጠበቅብናል ላልነው ያን ፎርም ያን ቅርጽ ያን ስራ እዚህ ጋር አሁን እዚህ ስቴፕ ላይ መስራት እንችላለን ማለት ነው። ያ ማለት ምን ማለት ነው? ሊሚት as the value of n approach to infinity, which is n times radical n minus n plus 3 radical n minus 3 over this, which is say n, the whole over, which is say n minus 1 over n. So we can apply in such a way. Now we can simplify. This is equals to the limit of say n over n root n over n, which is n by n cancel out, so which is simply radical n minus, so n over n is 1 plus 3 times radical n over n minus 3 over radical 3 over n. The whole over, which is n over n is 1 minus 1 over n is equal to simply 1 over n. The whole system as n approaches to infinity. But from this still we have the variables numerator and the denominator part. So which is radical n over n. So which is radical n over n. This can be when we want to rationalize the numerator part. This is equals to radical n over n multiplied by certain number 1. Nothing is changed. But technically this number 1 is equivalent to simply radical n over radical n. So radical n times radical n is equal to simply n over n times radical n, which is n times radical n. Therefore this n by n is cancelled out. The result is 1 over radical n. Therefore this radical n over n is exactly equals to 1 over radical n. Therefore from this part, which is equals to limits as n tends to infinity, radical n minus 1 plus 3 radical n over n means 3 times 1 over radical n, or else 3 over radical n minus 3 over n over this, which is 1 minus 1 over n, the whole system as n tends to infinity. Now when I apply the limit as infinity, this becomes the value of radical n. When the value of n becomes larger and larger, the value of radical n also becomes larger and larger. Without bound, it increases. Therefore this becomes radical n minus this is constant, which is simply minus 1, and this is 3 over radical n when n tends to infinity, since it is radical n becomes larger, 3 over larger number becomes 0, so the result is equal to 0. 3 over radical root 3 over n, when n becomes infinity, this becomes closer and closer to the number which is 0, over this becomes 1 over what? 0. Therefore, when you simplify this 0 minus 1, so infinity minus 1 is infinity, over 1 is infinity, so our result, which is equal to say infinity. Therefore, here the limit of the sequence n plus 3 over radical n plus 1 is exactly equals to infinity. The technique is that እዚህ ጋር የሰራነው ነገር ምንድነው? እዚህ የሰራነው ነገር ምንድነው? መጀመሪያ ራሽናላይዝ ማድረግ ኑሜሬተራችንን ዲኖሚኔተራችንን ራሽናላይዝ ማድረግ ነው። ራሽናላይዝ ለማድረግ ይሄን ቴክኒክ ተጠቅመን የተሰጠንን ኤክስፕሬሽን በአንድ ማባዛት ማለት ነው። ቴክኒካሊ ግን ያ አንድ ማለት ይሄ ኤክስፕሬሽን ራዲካል n - 1 ኦቨር ራዲካል n - 1 ነው። ኑሜሬተር በኑሜሬተር ዲኖሚኔተር በዲኖሚኔተር ስናባዛው እዚህ እንደርሳለን ማለት ነው። እዚህ ከደረስን በኋላ በሃይስት ዲግሪ ለሁሉንም ኑሜሬተር እና ዲኖሚኔተሩን በዲኖሚኔተሩ ሃይስት ዲግሪ ማካፈል ይሆናል። ስናካፈል ሲምፕሊፋይ ስናደርግ ለn ይሄንንም ለn አካፍለን ሲምፕሊፋይ ስናደርገው እዚህ ላይ ደርሰናል። ከዛ በኋላ አፕላይ ማድረግ የሊሚት ቴረሞችን አፕላይ ማድረግ ነው። ግን እዚህ ጋር ደግሞ ስናደርግ ራዲካል n ኦቨር n ወዴት ነው የቀየርናት? 3 ታይምስ 3 ኦቨር ራዲካል n። ይሄን ቼክ ማድረግ ትችላላችሁ። እዚህ ጋር ራሽናላይዝ ያደረግነው ምን ነው? ኑሜሬተር ፓርቱን ነው እንጂ ዲኖሚኔተር ፓርቱን አይደለም። ስለዚህ አሴንቴንስ ኢንፊኒቲቭ የሚለው ማየት እንዳመች ስለፈለኩኝ፣ ስለዚህ ኢንፊኒቲቭ ፎርም ወይም ቅርጽ እንዳይመጣብኝ፣ ስለዚህ ወደዚህ ነው መቀየር ያስፈልገኝ። ስለዚህ እዚህ ጋር ራሽናላይዝ ማድረግ ያስፈልጎኛል። ማንን? ዲኖሚኔተር ፓርቱን። ስለዚህ እዚህ ደረሰን። ከዚህ በኋላ ያየን ኢንሰርት እናደርግለት እንትኑ ያሳየና ስለዚህ በዚህ መሰረት በቀላሉ መስራት እንችላለን ማለት ነው። this is all about በእነዚህ ኤክሰርሳይሶች I think ኢንጆይ እንዳደረጋችሁ ተስፋ አደርጋለሁ። ለዛሬ እዚህ ብቃን። ሰላም።